The temperature gauge and ran the bike out of coolant, thus causing damage to the engine. We've already gone ahead and overhauled the water pump that was leaking and the source of the failure. And then we've gone on to refire up the bike and get it running again, determine the bike still has issues. With Robot's expertise, he knows that there is some internal engine issues, probably a warped cylinder head, possibly a worn out cylinder, who knows what. We'll get into that here shortly. But we figure, you know, Robot's done this half a dozen, maybe 10 times so far on Vespa 250s and 300 engines. Figured it'd be an opportune time to share some of his expertise with everybody at home. The other thing is this customer has actually opted to upgrade his components. So he's opted to go for the big valve Malossi cylinder head, as well as the Malossi cylinder kit with the larger displacement. So the ironic thing about the Malossi components is not only are they more cost effective than OEM components, they're undeniably better built. So silver lining, guy's got to rebuild his motor, but the blessing is he's going to be upgrading it and making a mini little rocket ship out of an already pretty peppy bike. So what we're going to do is we're going to go into the components that we're going to be installing. First and foremost, the Malossi components, as well as the other common spares that you're going to need for this type of process. And then, you know, we all know and love Robot. He's going to get dirty. I'm going to be helping him. We're going to show dropping the engine and basically, you know, overhauling the top end. So what do you think, Robot? Should we go check out the components?
Yep, show you the parts here.
Let's go check it out.
All right, here we got the Malossi cylinder head. Our part number is M3813273. And this is the replacement cylinder head. It actually fits the GT200 model, the 250 model, and the 300. It's adaptable for any of those motors. There's actually various passages that get plugged or opened up to use it on the various engines. I'll go into what needs to be done later in the video. Some of the differences between these heads, you can see this is a stock head. If you look at the valves, they're much smaller compared to the Malossi large valves. They're about 25% larger size on the Malossi head, and they're also higher quality. They're stainless steel valves. The actual cylinder head itself is made by the same company that makes the cylinder head for Piaggio in Italy, so a high quality component. All right, one thing about the Malossi cylinder head is you need to use it with the matching Malossi cylinder. The difference being is the actual piston has valve reliefs cut for these larger valves. Malossi makes basically 3 different cylinders, one for the GT200, one for the 250, and one for the 300. All 3 of those engines have different strokes, so they actually have different cylinders that are matched for those engines. The cylinder includes pretty much all the gaskets you need. I'll go over some of the other recommended gaskets that you should purchase along with the cylinder. Obviously the rings and the piston pin and the piston here itself. One thing about this cylinder, or all the Malossi cylinders, they're all aluminum construction with a Nikasil liner, and this holds up much better than the cast iron, dissipates heat better. They can run it actually a tighter tolerance than with the stock cylinder, so you gain a little bit compression. So it's just overall, it's a better cylinder. It's kind of what you'd find in a lot of race bikes. You'd find a cylinder that's aluminum construction with a Nikasil plating versus the cast iron cylinder that's found in the GT200, 250, and the 300. And Steve's going to go over the different part numbers for the various cylinders and what the actual cylinder sizes are.
So what we're going to go ahead and do is start it at the top and work our way down. So for the 300cc motor, that's the cylinder that Robot was fondling there. The part number on that one is an M3113958, and the actual bore on that is a 75.5. I'm not sure the exact increase in bore. I think it's pretty slight. So you're not increasing the displacement all that much, but like Robot said, it's like you're going from a run-of-the-mill cast iron cylinder to, you know, the top of the line basically cylinder technology with the aluminum stuff there. Then if you have like the 250 Quasar motor, the part number on that one would be an M3113928, and that's for the 250 motor. Again, the bore on that one is 74 millimeters. So I think you get a bigger increase in displacement with the 250 cylinder than you actually do the 300. Am I correct, Robot?
That's correct, yeah. You go from a 72 to a 74 millimeter bore, and I think it make, you know, the overall displacement, I think, is 268, somewhere in that range.
So that's a pretty good bump from the original like 245 or 248 that I believe the 250 actually starts at. And then the latest and greatest, actually, this is new to the market. Malossi actually just introduced this. Part number on this one is 381-3273. Actually, I take that back. The part number on this one is 311-3955. And that's actually the cylinder for the GT200. When Malossi first introduced this big valve head, they offered it and said it would quote unquote work on the previous generation of GT200 Malossi cylinders. However, you would have to purchase the special piston that had relief cuts at the top of the piston to clear the big valves. Malossi has gotten rid of that, and they've kind of figured the smart way to do it is to actually make a specific GT200 cylinder kit that increases the displacement significantly on that motor and works with this big valve head. So those are the three options as far as the cylinders go. I think that's about it as far as the Malossi head cylinder. Going to move on to a few of the other commonly replaced items when you're doing this type of engine overhaul on one of these bikes. Okay, so like we've said, we're going to be installing the Malossi cylinder head as well as the Malossi cylinder. The cylinder gaskets are included along with the cylinder. What's not included is some of these additional items that should really be replaced every time you do a service of this kind, dropping the engine, overhauling the engine on one of these motors. So what do we got first, Robot?
All right, doesn't include a spark plug, but an upgraded spark plug is the Iridium NGK plug, and that's a CR8 EIB. And also you're gonna need hose clamps. We sell these high quality German-made hose clamps for the water coolant lines. You'll need at least 2 of them. If you're taking all the lines off, you're gonna need 4 of these. And the part number on this is HCL12 soft. And on the 250 and 300 motors, they have a coolant bypass hose. That's about a 1/2 inch diameter hose. You're gonna need an HCL6 hose clamp. Might be a good idea to get 2 of them because the hose actually also connects to the water pump housing, but I'm gonna actually leave it connected in the case of this motor.
The Scooter West part number on the small hose clamps there is actually HCL6 Mini.
Mm-hmm.
So Robot recommends buying 2 of those. 2 of those guys right there, 2.
Overlooked, very important O-ring to change out on both the 250 and 300 motors this is underneath the thermostat housing. It's not included with the Malossi cylinder. And Steve has the part number for that little O-ring.
Part number on this, I believe this is the O-ring at the bleed screw. Is that correct,
That's
Robot?
correct. Mm-hmm.
So this is how you would actually, that's on the bleeder valve to actually purge all the air from the cooling system upon reassembly. Is that correct?
It's actually, it sits in a well on the actual cylinder head.
So let's show where that goes actually, if we can. Anyhow, the part number on that tiny little critical O-ring is 297027.
And it actually drops right into that little well right there. And we'll go over that when we're assembling the motor. So.
Okay.
And also, since you're opening up the valve cover, obviously take the whole motor apart, I'd recommend replacing the valve cover gasket and definitely replacing the 5 little sealing, constant tension rubber washers.
And the part number on the molded valve cover gasket is 829536. Again, the part number on the Scooter West website on this particular gasket here, 829536. That's the same gasket used on the 200, 250, and 300 motors. And then you also need to order quantity 5 of these special molded valve cover bolt O-rings. Is that what those are, Robot? Mm-hmm. And the part number on those is 830249. So in the grand scheme of things, you kind of see there's really not too many additional parts you actually need to buy and have on hand in order to completely overhaul the top end of the engine on one of these motors. So what do you think, Robot? Time to get dirty?
Pretty close. A couple other things I don't have here is, you're going to be draining the coolant. You're going to be draining the engine oil. You might want to look at our oil change and the coolant change videos, and they'll show you how to disconnect the hoses to drain the coolant. You're going to need to purchase coolant, purchase oil, a new oil filter. I'd recommend replacing the oil filter O-ring. A lot of times, if you're doing an overhaul of this caliper, it may be also a good idea to completely go through your transmission, put a new dry belt in there. You're going to be making a little bit more power, so you want to have fresh transmission components in your engine. And again, with this scooter, it had a coolant leak at the water pump. Any problems with your scooter, you definitely want to take care of you know, those kind of issues. You don't want to bolt this on, have a coolant leak, and burn up your brand new top end. And we'll go ahead and jump into pulling the motor out.
Let's go check it out. Gonna moonwalk over there, dude.
All right, got this motor transferred to a nice work surface right here. As you can see, it's sitting on the center stand and the tire, and nice and stable, you know, where we can just work on the top end right here. First of all, we want to start with taking off the valve cover. Steve's going to take off the 5 fasteners that hold the valve cover on. And while he's doing that, I want to talk about this motor and its problems right here. When you attempt to crank this motor over, it actually just doesn't even crank over, because right now the actual combustion chambers fill with water because of problems with the warp head and the blown head gasket. And you can even see in here, there's actually liquid water in the exhaust port. It's essentially hydrolocked. And whenever somebody talks about a hydrolocked engine, it usually means there's a liquid that's filled up in the combustion chamber. Engine's just basically a glorified pump, a pump of gas, you know, basically fuel mixed with air, which is a gas, and then also pumping out the exhaust gas. It can pump a gas because gas is compressible, but a liquid, you cannot compress a liquid. So basically, the piston, you know, basically won't turn over because it can't compress the liquid in the cylinder. It's not supposed to have liquid in the combustion chamber anyway, so, you know, essentially to try to crank it just feels like it's a locked up motor.
And again, that liquid was because the water pump failed, and basically the whole cylinder filled up with the mixture of coolant and water, which
is what happens
no
is the
bueno.
aluminum is prone to warping when it gets to a very high temperature, you know, beyond what its normal operating temperatures. And when these motors overheat, they generally warp the head and also sometimes score the cylinder pretty good. So hence why we're replacing these 2 top end components. You can see Steve got the valve cover off. You can see the valve train. They call this engine a 4-valve engine, so there's 2 intake valves, 2 exhaust valves. If you look at some of my tune-up videos, I talk about how to adjust the valves, but when we put this motor back together, I'll adjust the valves. Again, you know, obviously need to set the valve clearance.
And you'll see, here's the molded valve cover gasket that really should be replaced every time you kind of go into the motor. And the specialty 5, you know, rubber packings that basically go on these specialty fasteners that actually hold the valve cover on. So you can kind of see this thing goes like so, right?
Yep, like that with the new ones once we put it back together. A couple other things we need to do before we pull the rest of the top end off. On this side, there's actually a timing cover or a timing plug that inspect for a mark on the actual flywheel that indicates top dead center. You need a Torx T55 to remove that. It's not very tight. There's a little O-ring right there that seals it up. So went ahead and removed that.
You say it seals it, is that because is there oil back in there?
There's actually oil that, you know, basically underneath this cover you have the magneto or the stator alternator. It's a 3-phase alternator that generates the power, and charges your battery. And there's also a pickup coil and pips around the flywheel that tell the fuel injection, you know, when to squirt the fuel, how fast the engine's turn over, and when to spark the spark plug. That's all determined by the actual throttle body and what's communicated through that red and brown wire right there.
And we're not getting into it, but there's a gasket here because that stator plate is actually a wet stator plate, right? Like, i.e. it sits in an oil bath.
Yeah, it sits in an oil bath, and also the one-way clutch and reduction system for the electric starters all also housed underneath this cover. We're not going to touch it. We already had this cover off because I overhauled the water pump. Going to this side, the reason I have the belt cover off, even though I'm not servicing the belt, is I'm able to turn the motor over. And you can see this is really difficult to turn. I can actually kind of hear the liquid squishing around in the motor. It shouldn't sound like that at all. And normally you'd be able to turn this over, but I'm going to go ahead and remove the spark plug. It's going to shoot some water out and set this to top dead center before we actually take the engine all apart.
So Robot's gone ahead and removed the spark plug, and as expected, here comes the waterfall. Look at it. It's just dropping water droplets, drop.
And I'll show you how much water is actually in this engine. I have the spark plug out. Everything's actually connected. If you hook 12 volts to a starter, it actually will crank over.
You saw that? Do that one more time real quick, Robot.
All right. Look at that.
Poof, 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 poof. It's actually cool. You can see the valve train working and stuff like that. And like Robot said, that should normally not be squirting mist out of there like Bridal Veil Falls.
All right, I got the belt cover off so I can easily turn the engine over to set the valve train and piston to top dead center. You could see the cam chain right here, and we're going to go ahead and turn the crankshaft counterclockwise. You can see the intake valves are actually coming up, which means they're closing. And you'll see some marks on the actual gear under here. The first mark you'll see is, says 2V, and that's for 2 valve. This engine isn't the 2 valve engine, but the sprocket's actually used on engines that use 2 valves. But we're looking for the mark that says 4V, and I've marked those with red paint along with the reference mark on the very center of the head. So basically I'll get the little arrow, the pin of the cam chain itself, and the center mark all lined up. And now it's set to top dead center. Basically this is when you would adjust your valves. They're all loose right now, which is normal. You know, when you're at top dead center, all the valves are completely closed. If we flip it around and look through that timing inspection plug hole that I removed in the previous step, you'll see a scribe on the actual flywheel that will align up center with the actual hole, indicating your flywheel's at top dead center.
So those are the two ways to set and double check top dead center.
That's correct.
And keep in mind, this red paint is just something that we did for the sake of the camera. You're just gonna have a little cast aluminum line there, and then the marks on the sprocket, but hopefully that's more visible for the sake of the video.
And one thing with 4-stroke engines, basically your engine turns, the crankshaft turns 2 times for every 1 time your cam turns. So you may need to turn that 2 times. Basically, if I turn this 360, this mark will be 180 over here. So that's just the way a 4-stroke cam drivetrain works, essentially, you know, to actuate the valves.
So now we're safely ready to start disassembling components and taking the cylinder head off. Is that correct?
That's correct.
All right, let's dive into that next.
All right. Got a couple more things to disconnect before we pull the cylinder head off. You got your coolant bypass hose, which has a small OEM style clamp on it. Go ahead and pry that, much like the steps we had in the earlier hose removal.
And you said you find this bypass hose on which engines?
It's found on the fuel injected 250s and 300s.
So not on the GT200.
The GT200's got a different bypass system, and we're not going to talk about that now, but go ahead and disconnect that. You can get better access to this other hose right here. Again, you can kind of see you just take a good pair of dikes and give them a good twist, and you're able to pull them right off. Again, we're going to replace those with high quality worm gear clamps. Sometimes these hoses are a little stuck on here. You also want to inspect these hoses. If they have any swelling or cracking, definitely a good idea to change them out. They're pretty inexpensive. We stock the whole set of rubber hoses for these models of scooters here.
A lot of times I know, like when a hose wears out, it'll get a little bit of a soft spot, and they'll kind of get a little fat, like they're almost growing like a bit of a growth there, and they'll be kind of real spongy and soft. So that's what Robot's talking about.
Yeah, and you know, if a lot of oil's actually gotten on these lines, that would also cause them to swell and have issues. Steve's going to go ahead and take off the 2 accessories that are on the actual cylinder head that are going to get reused on the new cylinder head. That's the thermostat housing, T25 wrench, take the 2 fasteners.
Kind of pry it up gently. You notice the thermostat comes with it. Thermostat pulls out. Does it just pull out?
Yeah, usually pull right out.
There it is. So you got the
gasket's
thermostat.
actually staying with it. One thing to keep in mind, these are prone to leaking. You cannot buy this actual seal. You can only buy it with a thermostat. If you're going to reinstall it, you want to put a small amount of silicone on the actual.
And almost looks like it's got some silicone from the factory too. You can actually see some residual stuff.
Yeah,
is that true?
That's always been a problem with these, and sometimes these get warped, you know, when they're overheated. So
I'll definitely say from the spare parts side of things, we saw quite a few of these. And what can you tell us about this little bleeder screw too? That's another popular item.
Yeah,
and that's like a long needle looking thing that actually threads down in there. Is that correct?
That's correct, and it actually opens up that passage that we talked about needing that extra O-ring. You can see it's right there, that little passage. You actually unscrew this like 2 or 3 turns, and opening that passage allows the air to come out of the top end of the motor. So it doesn't, when you change your coolant, these engines just kind of weigh the cooling hose arrangement. They're prone to, I think it's captivating, which is basically air pockets in the cylinder head or in the water pump. And that bleeder screw allows you to bleed that air out. And if you look at my coolant flush video, it covers how to correctly bleed the coolant bleeder system found on these 250 and 300 motors.
The long and short of it is bleeding the cooling system is an absolutely critical step when it comes to rebuilding these motors. Wouldn't you say, Robot?
Yep. The 200s, you actually, a lot of times you physically want to disconnect the upper radiator hose to allow the air to come out. Steve just removed the coolant temperature sensor. This basically sends a signal to the fuel injection on the engine temperature and also controls a gauge, you know, the temperature gauge. Use a 21 millimeter deep socket. If you don't have a 21 millimeter socket, you could also use just a wrench of some sort. Yeah, to disconnect that.
Now we're going to go ahead and spin the motor over, going to cut and get ready for the next round of parts to remove.
All right, before we can remove this cylinder head, we need to disconnect the valve train. Again, it's all set to top dead center right now. First step you want to do is remove this bell that's part of the auto decompression system. And basically you want to hold the flywheel. There's also a holder, but I'm not going to go into using that tool. But basically loosen that nut.
And what does this auto decompression thing do, or does that really matter for the folks at home?
Basically on these motors, they're able to use a smaller electric start system by having this auto decompression system. This little thing is a counterweight right here. And basically when the counterweight's in, it actually holds your exhaust valve open a little longer. That actually lowers your theoretical compression when cranking the engine over at the cranking speed. So it allows the engine to start a lot easier. Once the engine comes up to speed, this little counterweight actually comes in, makes contact to that little rubber pad in the bell, and it deactivates the auto decompression system. And once the engine's running, it's now at the full compression ratio. It's just basically no longer has this extra little lobe that holds these exhaust valves open a little longer. And this is found on the 125 motors all the way up to pretty much most of the Piaggio motors. There's some extension. Some of the 125 motors, all the 50 motors don't have them. The MP3 400 for some reason doesn't have it. But
so essentially an aid in starting.
An aid in starting.
And what is the wear rate of any of these components? Pretty rare?
I've never seen any problems with them.
Okay.
Very reliable, but there's some small parts you don't want to lose down your cam chain tunnel. Basically, you got this little spring. I'm going to go ahead and pull that off. We'll go ahead and I'm putting my finger behind here, and the reason why I'm removing that counterweight is I was actually holding this little plastic spacer. And
nice
this
tip,
spacer,
Robot.
there's actually a little problem with it. I see that's been melted, and that's probably from the extreme temperature. They normally look a little wider than this and aren't melted like this one, so we'll go ahead and replace that part. Little problem there with a motor that's been overheated. This other part of the counterweight is 4 millimeter Allen. Steve's going to hold the flywheel, and it's pretty tight. Wow, I think I might have to get a bigger wrench. All right, this thing has definitely been a little bit of a bugger. All right, now I finally got it broken free. And just to show you, this fastener, see how it's like a little bit rounded out now? So you can see how the tool doesn't really fit in there that good. Be a good idea to replace that, and that's what we're gonna do. Whenever you kind of damage a fastener, removing it, always replace it. Don't mess around with putting it back in. So again, that shouldn't have been that tight. That little fastener normally is like, little 5 millimeter guy like that. It should be only like a few foot-pounds. It shouldn't take 50 foot-pounds of pressure on this thing to break, but that's what it took. We got it out, and we're gonna replace that. The little counterweight comes off, boom. Next, I'm gonna take the cam chain tensioner off, and before I actually jump to removing the cam chain tensioner, you wanna actually pull the center spring out. So that's the center, break that free, and there's two different types on these Piaggio engines. Some have this aluminum crush washer, and some have an O-ring, but this one's got the crush washer. Go ahead and take that off. Then you want to remove the two 6mm fasteners with a 8mm wrench.
And this was a 10mm wrench on that center cap thing that's got the spring tension on it.
Yeah.
For everybody at home.
And one thing, we're always keep the engine at top dead center, even though we were cranking on some of those fasteners. Take those two little guys out, give it a little pop it off. And the reason I took that little spring out, because if I left the spring in there, it would push this little plunger out. And basically this little plunger keeps pressure on your cam chain. And that actually, just from looking at them, that looks good. If you had a worn out cam chain, this thing actually would be about like that. See how it sticks out more like a 3/4 of an inch? And to reset it, you push that little tab and push it all the way in. And it was, you know, as the cam chain wears, it keeps on coming out. It's like a one-way little ratchet clutch in there. Just kind of showing you how that works. Again, if it's all the way out, you're gonna need to replace the cam chain. Generally, these cam chains don't ever really have any issues, this style cam chain. I've never really had to replace one. Even on motors that have like 60,000 miles, it's still in pretty good shape.
And this is stating the obvious. When we put that back in, it'll be fully depressed and the thing will automatically push itself out, right? I mean, there's no adjustment with this. It sets itself automatically and maintains that pressure on the cam chain. How often would you need to replace like the cam sprockets? Virtually
never, but if you had some sort of damage.
So again, in the case of this motor, we did note that we kind of filled the crankcase with water. Like that kind of stuff wouldn't potentially damage this stuff. Maybe if it was done excessively or something like that. But for the most part, if you do it one time, like even all these components are still reusable.
These metal components tend to survive just fine with a, you got this little plate, Mickey Mouse here, see there? There's Mickey Mouse. And there's Mickey Mouse with a big smiley face, see that? Right there. So take those two guys out, cam chain's hanging. And now we're gonna go ahead and break these two fasteners beside the cam chain tunnel, and Steve's gonna break in the 4 fasteners that retain the head to the actual cylinder and engine itself.
So here we are, we're gonna remove the 4 head bolts. We've got a nice 12mm deep socket. And just like removal of any cylinder head, you wanna kind of crack them loose in a diagonal pattern. I think these things actually all get step torqued down. Robot will go over that when he reinstalls everything. But as soon as the tension's off of them, you can kind of just go ahead and completely remove each of the fasteners. As a construction guy, Robot's put one of my favorite tools in my right hand here. Got a nice little rubber tipped or small dead blow hammer. 4 fasteners removed for the cylinder head. Robot's instructing me to kind of gently tap, see if this head comes off. We've got a pan here because we're expecting more water to come dripping out of this once we got this off. Oh yeah. Spoogeville. So now that it's loose, you can kind of just wiggle it back and forth, and voila. Those are the cylinder nuts. Don't mind that. A lot of times, I think Robot was saying there's these 2 alignment dowels. Sometimes the head will kind of bind up and get a little stuck on that. But you can kind of see where there's this kind of gooiness. That's basically where the water and oil have basically failed to mix, and that really should never look like that. But that's kind of the common stuff you see when a head gasket fails. That kind of chalky, white, sludgy looking stuff.
Then with the head gasket itself, doing a little analyzing right here, you can see it's kind of a little burned away right here. Not too bad, but as I suspected, I've taken a number of these apart that have been overheated. It's usually a warped head, and that's it. It's not worth the time or money or effort to really resurface those now that Malossi has a replacement head that's superior in many ways. The dowels come right out. They usually come out just pretty easy.
And we're going to be reusing those dowels, obviously.
That's correct. If you distort them, you want to replace them. I've never really seen issues with these ones. These ones come out pretty easy. The ones on the base, sometimes they do have problems, and you'll see those next.
So we've got the head off, and we've already talked about some of the white sludgy stuff from the oil and water mixing, like it never should. Robot's kind of corrected me because he said that the only way to actually check this thing for warpage was with the straight edge and feeler gauges, per the same way you would check any cylinder head for warpage. So the crappy thing about these things, you actually have to remove the valves in order to put a straight edge across there because of the way that the valves actually protrude. Again, we're not going to get into that for the sake of this video. We know this thing is basically trash, so we're not going to get into it. So this is the one that came off again. You can kind of see how burned up and caramely and kind of gross looking it is. This is a decently clean used head. Panning back up to the cylinder here, you can see the water jackets, water passageway there, and there. Robot said that one down there is an oil passage. Is that what you said?
That's correct.
And that's the only oil passage. Is that also correct?
Yep.
And then you can also see on top of the piston, where Scott zooms in here, you can kind of just see, we haven't wiped this off yet. There's just that really thick, kind of gross, sludgy mixing of the oil and water. And Robot and I were both kind of commenting in the break there how there's that certain aroma that only like burnt oil basically puts off. Just really, really gross. So that kind of pungent smell that we've been noticing all along on this project. So what do we got going on your side of the engine, Robot?
You got your cam chain. You know, the engine's still top to center. You know, if I hold the actual cam chain, you could actually see the motor, you know, pump up and down. And, you know, cylinders, it's a little crappy looking there. It's not the worst I've seen, but.
And what would you be looking for? You'd obviously be looking for galling and scoring and stuff
and
like
galling. We'll take a look at the piston, but again, that's getting replaced, so I'm not too worried about it. Before we move to cylinder, there's this little guide. Pull that out, actually give it a good look, because this is, you know, it's a plastic that can handle high temperatures, but you know, if it's distorted or you see where the cam chain's actually worn a groove in it, maybe a good idea to replace it. Generally, these hold up pretty good. This one stays with the actual engine. We're not going to touch that one. Remove the cylinder here. One thing to keep in mind, there's actually O-rings in all these plugs right here. And we're going to actually loosen it. Give it a couple little taps, see if it rocks away from the actual crankcase itself. I can see it's starting to break the gasket. And frequently the dowels on these bottom two here, they're smaller dowels. That's the only two spots they use a dowel. Those frequently are rusted into the case. And again, a little more finessing to get this off. So there we go. So gasket's breaking away. Dowels are one staying with the cylinder. You can see that. And one thing that keep in mind is those O-rings are actually kind of binding it up, making it a little bit harder to pull away. So this one's being a little more difficult than normally what I see, but.
And what Robot's doing with his left hand here is he's got his fingers clutched around a casting on the cylinder, and he's putting downward pressure with the palm of his hand on the cylinder stud, so he's kind of drawing that thing off as evenly as possible. But like you said, yeah, it is fighting him a little bit, but it's close.
Getting pretty close, and one thing to get those O-rings off there, I'll kind of show you with the trick. Basically, I'm getting those O-rings up to where the threads are on the stud, you know, and they're not going to want to go past those studs too easy. But once you get to that point, kind of make sure you don't damage this cam chain tensioner. But we're actually going to go back. See how I push the cylinder back in? Now you're able to remove those crispy old dried up square O-rings. Don't want to ever reuse these things. Just throw them away. So got two of them. These two other wells are actually a little deeper because that's where the dowels actually go in. So we'll try that again.
So we'll kind of repeat that process. This time the cylinder is going to come up a little bit further. Robot with his expert feel is going to be able to tell when it's about time to drift it back down.
And again, I think they've caught the O-rings. Don't worry about the cam chain. Just leave that right there. You can see my engine's pretty clean, so it not getting dirt on it or anything. And there you go. So that's how you actually remove those O-rings. Get them up to the threads. I mean, you could use a pick to pry them out, but this works
better,
just fine. So
those are the tricks of the trade right there. It's the simple stuff that saves times and makes stuff cruise along smoothly.
So now the cylinder may need a little bit more tapping still. It's pretty gooed up on there, but go ahead and we're going to take it all the way off.
Okay, that's perfect.
There we go.
All right, so we've gone ahead and removed the cylinder and got it the rest of the way off. Notice how rusty it is. It's not the worst we've seen. You can still see some cross hatching from the honing in the internal cylinder walls there. There's no real heavy scoring, but again, we're not going to be replacing this, so we're not going to spend too much time checking stuff out. But just quick demo, this is actually that Malossi piston. And you can kind of see how much larger the actual bore is on that Malossi piston. Now that would never, you know, you can see the increased size in the bore with the Malossi piston versus the stock cylinder. I flip the thing back over and you'll see those two dowels, 1, 2. One of them stayed in the crankcase. Robot's going to extract that one and transfer it into the crankcase once we're ready to start reassembling everything. Robot, what's up?
All right, going to remove the gasket. One thing to keep in mind with these Piaggio engines, they actually have 3 different thicknesses of these base gaskets. Nearly every single motor I've ever taken apart, they always have the middle of the 2 gaskets, which is a 6/10 of a millimeter. The gaskets included with your Malossi kit is a 6/10 of a millimeter gasket. Seems to be ideal for pretty much all all installations. There's a factory tool for checking the squish clearance, but the 6/10 gasket will work just fine. The one dowel came out of the cylinder with no problems, but this dowel is a little bit rusted, into the actual, the actual crankcase, and we're going to remove it just so we could scrape and clean the thing. But see that one pulled right out, looks pretty clean. This one, if you take a needle nose or something and start squeezing it, they're really thin. You'll just end up distorting it and essentially ruin it, throw it away. They're not all that expensive to replace, but a way to remove them is you find some sort of round object, whether it's a slightly larger screw, but something that fits snugly into the actual dowel. And now if you squeeze it, it's not going to distort it. And you can grab it with whatever and kind of work it, with that in there, and it doesn't distort the dowel if you're squeezing it while it's on a rod. You can see how nice it fits on to this rod that's part of a Torx driver. But you can find something like that. Little tip.
Nice little trick of the trade. When I start to look at this piston here, Robot, it almost looks like there's rust starting from that oil scraper ring and like seeping its way down the skirt of the piston.
Yeah, you can see the whole ring is full of rust. And, even though technically you could probably use this, the piston doesn't really have too much scoring, this rust is going to wear out these rings at extreme rate. So hence with the water in the top end, you kind of just have to go through everything. You can't, may have compression right now, but it's not going to last long at all.
Sounds good.
That's why we're replacing all the parts in the top end.
So up next, we're going to go ahead and remove the piston, and we'll show that in the next shot, right?
Mm-hmm. Yep. All right, Steve packed the cylinder with some clean rags, and that's to keep this piston clip that I'm going to remove out of the bottom of the engine. A lot of times this clip, they go flying when you remove them. Basically, there's a little relief cut in the piston in this corner, and that's right where I have the needle nose, inserted. A real nice set of needle nose. These are my Matco ones. They're really good. And when I twist them up, I just give them back to the Matco guy, and he gives me a new set.
Certain things are worth buying good quality ones.
You don't want to have crappy ones that slip off the ring. It's a round ring. So basically, you get the needle nose in there, and you kind of like push in and pry out. And there you go. I pulled that out without it flying across the room. But we're not going to reuse that. The Malossi kit comes with a new clip.
And Robot, that little notch you was talking about, that's where you kind of go and get the end of that, right?
So
like that.
So it's a nice set of small needle nose that have a serration in there, happen to work perfect for that. There are special tools, but I'm not going to go into it. I'm going into using tools you can have at home easy. The pins you generally push out. If it doesn't push out, the pin may be seized to the connecting rod, and you have more problems. You probably need to replace the crankshaft. And I'll see that on motors that have run out of oil, where this pin is seized up on there, or the big end bearing is blowing out.
So that was a simple little test because you could push that pin out so
pushed out so
easily.
Yeah, no, I don't think there's going to be any issues with the small end of this connecting rod. Again, if the motor's been run out of oil, you might have more problems than just a seized up top end. You may have issues with your crankshaft or crankcase, but we're not going into that problem. This thing was only overheated, it wasn't run out of oil, so there you go. So pull that off. The actual pin looks really nice still. Looking, just visually inspecting, I don't see any sort of galling whatsoever in that small end connecting rod. This has you know, real nice tight feel to it, but easily slides side to side. And that's kind of what you want to do. There's specifications in the book if you have the special bore gauges that actually measure that. But, you know, just doing that test is good enough to tell you looks good, and this has a real nice, you know, slides easy through there with no free play whatsoever up and down.
So that's it. I think it's time for me as the grunt to kind of start cleaning the rest of this gasket surface so we can actually get ready to start reassembling everything, right, Robot?
Correct, yep. And basically clean the surfaces of these studs. You want to carefully scrape all the remnants of this gasket. Do it with a X-Acto blade or a straight edge razor. There's specially gasket scrapers to do that. One thing to keep in mind, along with keeping the gasket bits out of the crankcase, you also don't want to have any contamination go into this this oil
passage. Right?
Passage hole. And in there, if you're familiar with carburetors, it looks like there's a carburetor jet in there, and that's a special metered passage for that oil. And if you do get anything in there, you can actually carefully remove that and clean it out. But we're just gonna carefully, you know, there's not much gasket material right there, so I'm not too worried about anything going into that.
What I'll do is I'm scraping, I'll kind of keep my finger over that just as a precautionary thing. So we'll get this cleaned up and then cut them back and show you the next shot.
Yep, and this side tensioner looks good. You have to take the motor much further apart to replace that tensioner, but it's in good shape. Don't need to replace it. All right, before we put the motor back together, or the top end back together, there's a couple things we need to salvage from the old head, and there's a couple items we actually have to prep on the new cylinder head. I'm going to go ahead and take the rest of the valve train out of this engine, or out of the old cylinder head, and inspect it, and hopefully it's all salvageable. You got the cam itself right here. There's two fasteners that hold this thrust plate. Actually keeps the cam in place. Go ahead and loosen those two. Take this little plate out. You know, inspect it. Make sure there's no excessive wear or grooves in there. You know, if this is worn, you probably have a worn out camshaft along with, you know, that plate. Since it's a top dead center, the cam will actually pull right out. No problems here. And just look at the surfaces of the actual lobes. There shouldn't be any scraping or any sort of like metal that looks like it's flaking off. Same with these two journals. This is the two cam journals that ride on oil in the actual cylinder head. This cam looks like it's, you know, definitely in good shape. A couple little holes in here. There's actually, they pressurize this cam with oil, and you know, the oil actually comes out of those little holes. You got the rocker pins. I like to keep them. They're identical, both the intake and exhaust side, but you know, I want to reuse them and put them in the same spots. You know, this is our intake side, that's our exhaust side. Usually I clean things up and I'll mark like E for exhaust, N for intake. The actual rockers are different between the two, but just so they don't get mixed up, I'm going to go ahead and mark those too. So I for in, E for exhaust. So I'll pop those out. You know, you use something, you know, other than my little pinky. There we go. Something to kind of push the actual pin through. One thing to keep in mind is you want to loosen these lock nuts too. It makes it a little easier when you put it back together. You know, so loosen the two lock nuts. Pull that out. Pin looks good, no problems there. Look at the hard facing on the actual lobe that actually rides the cam. That looks like it's in good shape. So there's my intake. And do the same with exhaust. Loosen up the two little things. I already cracked the lock nuts. Pull that out. Everything looks good. And there you go. Those are parts that can get salvaged. Everything looks good there. I don't suspect there's any further issues. If you suspect a lot of wear, there's actually measurements for the lobe height and actual base circle of these cams in the factory service book. But they're definitely in serviceable, usable condition. So we'll go from there with those parts. All right, we're going to go ahead and prepare this Malossi cylinder head for the application we're going to use it on. Again, this cylinder head fits multiple models, and different models have different ports, and you know, there's air injection on some of them. I'm just going to show you what we got to do for this 300. And this basically, I guess you'd set up for the Euro 2. If you look in the actual book that comes with the cylinder head, it talks about what passages to plug and which ones to install the little spigots. And these are the various parts that come in a bag. For what we're going to do, we don't need this one. That one's actually for a different thermostat sensor. This is a plug. This is another little plug screw.
And
we're not.
That robot, could you use the original cylinder head as like a cheat sheet kind of?
Pretty much, yeah. If you look at the
Right?
Yeah, if you look at the original cylinder head, you're going to see, well, there's a spigot here. Right on this Malossi one, there's actually a threaded boss. Well, the spigot kind of looks like that. So, little crush washer right there. Pop the crush washer on. Go ahead and thread that in. And that's a 15 millimeter. And you can use the box end wrench and just go ahead, and snug it tight. So that's the one passage we do need for the coolant bypass. There's these two little ones that are used on the GT200. Is what kind of throws people off. You usually think, well, it's going to leak coolant out of these. Well, ironically, these are actually not drilled all the way through. So I'm going to leave this one alone, but this one actually sticks up too high for the thermostat that's on this engine. So you need to take a hacksaw and cut this down. You don't want to cut it flush, but cut it down to where there's about, I would say 5 millimeters of the actual spigot still remaining. So go ahead and use like a little hacksaw or something. Carefully cut that off. Obviously you can get some metal shavings, in the cylinder head. You're gonna blow this out or clean it out with like carburetor spray or something. So I'll go ahead and cut that off. This hole is fine. This is for the thermal sensor. And one last thing you want to check on these is fill each one of these, both the intake, fill it with water and kind of wash the valves. If there's a little drip that comes out, you may need to tap on these a couple times to make the valve seat. And if it still is dripping, you may need to take the actual valves out and lap them to the head. Every once in a while, you got to take them apart, clean them up just a little bit. Mostly a couple little taps to the top of the valve will allow the valves to seat. Same with the exhaust. Basically fill it with water, kind of watch to see if there's a weep that comes through. And otherwise, put the cam back in. This being the exhaust. Rocker that I marked with the E, we'll put that on that side, vice versa. When we put this all back together, we're going to actually coat this thing with assembly lube. If you don't have assembly lube, you can use like a thick gearbox oil, something to just give it a good oil coat for its initial startup. Because when you first start the motor up, there's not much oil up in the top end, and all these passages are dry. So it'd be a good idea to coat everything so it's not running dry during the first few seconds of startup. All right, so we'll go ahead and prepare this, and we'll jump into the assembly of the top end, putting the cylinder on. We're getting pretty close to putting this piston on.
Hey, Dr. Robot?
What's
I got a question for you.
Tell me all about it.
Well, I mean, customers that blow it more than this particular individual and run the things out of oil, a lot of times they need to order crankshafts from us. There's two different part numbers for the crankshafts. There's a category 1 and a category 2. And I know every single time on the part side, we come scampering over to service to be like, hey, Dr. Robot, how do we tell if a customer has a category 1, category 2, and how the hell do we explain that to somebody? I see some numbers here, and I suspect that might have something to do with it. So can maybe you just elaborate on that real quickly?
Okay, yeah, I can. Basically, yeah, if the crankshaft was going to be replaced, they have machining tolerances to these the journals in the engine case for the mains, and they separate them into 2 categories. The funny thing about this engine, it says 1 on one side and 2 on the other. I've seen that on a number of Piaggio cases, but most of the time it says 1, 1. That means it's most likely a category 1 crankshaft. If it says 2, 2, category 2. Unfortunately, sometimes you see them where they have 2 different numbers. The only way to really accurately check is see what crankshaft's in there, and hopefully it's the correct one for the journals, or completely take the engine apart and measure the journals with a bore gauge. Generally, you just replace it with the same crank that's coming out. So the way to check is you go to bottom dead center on the crankshaft.
Move your hand down if
So-
you can.
we're going to go ahead and crank the engine over. And you're going to see some engraved numbers in the very bottom. I'm not all the way there, but basically I see 03/09 star 1. It basically means it was made in March 2009. In the star 1, that's the actual crank. It's a category 1 crank, and it says the same thing on the other web, you know, star 1. If it was a category 2 crank, it would have star 2. And again, those first numbers are just a date code, you know, for when the crankshaft was manufactured. So if I was replacing this crank, I'd put a category 1, even though this engine case says 2 and 1.
1, 2. Crazy.
Yeah. And again, if I want to take it a little further, I'd measure the actual journals for the actual main bearings in there, the main. All right, so we're going to go ahead and prep the piston and cylinder for installation. A couple things we got to do. Piston doesn't come with any of the piston rings on it. You want to keep everything really clean. You know, have clean rags. You know, don't get grease on this. You got your pack of rings right here. Of course, every time you open a little Malossi package, you get the Malossi sticker.
Fastest stickers in the West.
You got a couple funky different rings. You got this little coily ring. You got two of these same real thin, kind of like real thin rings. All these three rings there are the oil control. You got this ring that kind of is a dark cast iron color. That's your center ring. Then you got this one that's kind of like a bronze color with a kind of a silvery edge, and that's your top ring. So there's your 5 rings, or basically it's 3 rings. The oil control ring is a set of 3 rings to make, you know, the oil control ring. We'll start with the oil control ring. One thing, you look at this piston, kind of looks like it can be installed either way. There's a real small little engraved arrow. That actually always points to your exhaust. And on these engines, your exhaust points down. So we're going to work with this piston pointing like that. You got your oil control, like spreader, whatever, you know, tension ring. Got the gap. I'm going to actually put the gap right in the center. So 180 degrees from that little arrow there. And it's not too critical. If it gets off by, you know, whatever, 10, 20 degrees, it's not the end of the world. Then you got these little guys here.
Is there an up and down on?
These two, there is not an up and down. On the other ones, they're actually marked, you know, that they have an up and down. We got the gap here. You know, I'll go maybe around 2 o'clock right there for that gap. And I'm kind of setting it in the top section of the of that little funky coily ring. And it's a kind of a fragile little ring, so you kind of got to work it. You can see how it's kind of like wanting to walk on the bottom. You know, and sometimes if it gets a little wonky, you just want to carefully pull it back out and try again. You know, so, and don't, you know, drop in the other groove. Don't want to do that. Basically, just get it right in the top. And this is the hardest of all the rings to install, is this oil control ring. So there you go, and the gap's about at 2 o'clock right there. You know, you make sure it kind of drops in. You could see that part of this this little spreader ring actually kind of is overlapping. You don't want it to do that, so I'm actually going to pull it back and try again.
While Robot's playing around with the rings, you notice I've kind of jumped onto the wrist pin in the cylinder. We've just got some diluted purple spray, or you can use simple green, any number of degreasing kind of products. Just put a little bit on the wrist pin, because you notice there's like this kind of like varnishy stuff from the factory, keep it from rusting. So do that on the wrist pin. That'll make it so it'll slip in nice and easy. And then we've done this in other videos, so you can refer to those, but same thing with the cylinder wall. You kind of want to just give this thing a liberal kind of dosing down. And you kind of, ideally with like either white paper towels or white terry cloth, you want to wipe this down until it's nice and clean. You notice I just said use white towels, and I'm using a red mechanics rag. That's just because I'm doing the initial one with this red rag. But you can kind of see the discoloration in the gray and kind of the, I don't know what you would call it, manufacturing slag or dust or whatever that's building up on the rag. And once we move over to the white rag, we'll basically continue to spray it and wipe it and wipe it and wipe it until it gets nice and clean. And that's basically how you prep the cylinder to get it ready for installation. All right, Robot, did I miss anything?
No, that's good.
Let's check back in with the Roadster, see how it's doing with those piston rings.
Yeah, struggling a little bit with it. Normally,
He's taking his time. I mean,
yeah, sometimes, I don't know.
by our standards, it's still early. It's not
Yeah.
even not even 10:30.
But yeah, don't really want to mess these up. Make sure they're all seated in the spot. And I keep on feeling, I don't know if you can see in the video, but that little coil spring, you know, is kind of like overlapping. You don't want to do that. So, you know, you may need to try a couple times. You know, I'll try installing this ring from the bottom. And that might have been the trick right there. So there's that ring.
So what was actually happening? The actual like coily tension thing was like overlapping?
Overlapping itself.
Got it.
And these rings are very fragile. I mean, if this gets folded over, it's just ruined, you know. And basically the bottom one, I have the gap more or less at like 10 o'clock. And I could try again with this upper of the two oil control rings, putting the other one at 2 o'clock. And should be good. All right, I think we're in business. So you see the little gap, 10 o'clock, 2 o'clock, and then the coily ones right at 12 o'clock. Next one we're gonna put is the kind of cast iron ring. It actually has a direction it goes up. You see the little end down there? That actually faces up. And I have a special tool that actually spreads rings, but I'm not going to actually use it. I'm going to put this ring, you know, would you say that's at like 8 o'clock or something?
Yeah. So the bottommost ring.
This is going in the center of the 3 grooves. That much easier than that oil control ring, but there you go, somewhere about there.
So what you always want to do is you kind of want to stagger the ring end gap. So he's got one ring there. I think that final ring is going to be right about there. That tension one was there.
The other one's there, and
there.
that one there.
Sometimes it's kind of nice to put simple little reference points just so you got a good way to kind of keep an eye and pay attention to where you're at.
Again, top ring, it's got another little in. Go ahead and walk that little ring in there. So all the rings are all set. You know, they all turn freely in the grooves. Pretty much ready to go into the cylinder. One last thing I'll put in is one of the 2 clips. You see there's 2 clips for the pin, and the one I'm going to put in is the side that's on the cam chain. It's the harder side to access while you're working on the engine or working on installing the rings, or install the clip while the piston's on the engine here. Oh, here it is. I got it. Oops. Not good, misplacing tools. So there you go, I'm grabbing this little clip right here. Another little tip sometimes, if you're struggling with it, you could actually install the pin. You know, the pin kind of, you're basically putting the pin in there as a stopper. And see that first edge? I'm gonna actually hook it into where that hole is. And basically, I'm kind of rotating it and pushing it in. And I'm also using my finger to kind of hold it in place. And it didn't quite all the way go in there, but you can see how part of it is installed. The other part's kind of popping out. I'm keeping my finger over it so it doesn't pop out. You don't want to have to lose the clip. And then just use something to press it in place. So it popped right in there. You kind of look at it, make sure it's all the way in the groove on all sides. So definitely is. We're good there. So
yeah, and from where I'm standing, I can actually hear that thing click into place when it finally seated.
So this is ready to go. Again, if the rings get a little off, it's not the end of the world. So, all right, ready to put the piston in the cylinder. We're actually going to put the piston in the cylinder versus putting the piston on a rod. Makes the job much easier. Little dot of oil there, little dot of oil there. That's just on the skirts. That's all I'm putting is just a little bit of oil. Not getting crazy. You don't need to put a ton of oil on everything with these newer motors.
Should I finish cleaning this, or we can get back to that?
You still doing some cleaning on that, Steve?
Well, I was.
Okay.
I don't know what the hell I was doing.
But
I was just mesmerized by the robotic magic.
The pin, you can liberally oil that up.
This will be close, actually.
Yeah, so get a little oil on that, and I'm going to actually get it started. On the side without the clip. Basically, it's going to go that direction. I'm getting maced by that purple spray a little bit. Start coughing a little bit. Oh, there's a real cough.
It's tough. I was just about to make some smart comment how I'm a crack baby and it doesn't faze me, but.
It was phasing you.
Yeah, exactly. I'm not a complainer. I love it.
Yeah,
Right.
if you want to do the El Natural cleaning, you can just use soapy water. You just got to work harder, more elbow grease. But if you want to use detergent, it might take a day or a year off your life, but you know, it cleans a little bit better. And you get the little cough that goes with it.
Nice and clean, so we can tell the rag is actually coming out clean, so we're ready to install this. One final thing. Oh, look at
what
that.
a piece of junk. Oh,
Don't-
look at that.
Don't buy these things on Amazon. God, you see a 20 pack for $4 and think, God, those are gotta be the best spray bottles ever. Not. We just broke a tool. It'll happen. All right, what do you say, robot? Clean
Looks good enough to me.
Okay.
Yeah.
Sounds good.
And you want to oil the cylinder, and I'll show you how much oil you want to put on it. See that? Some people sit there and squirt tons of oil. Now all you need is a drip. Like there you go. Like I put 2 drips in there. And then you just work that one little drip everywhere in there. Oil the whole thing with that one drip, like on both sides. And guess what? Whatever residue is left, you wipe it all out. That's all the oil you need for a cylinder. With these Nikasil cylinders, they don't need much at all. So,
Nice.
and if you over oil it, oftentimes the rings actually won't seat correctly. So it's more important that you do very little oil. It kind of sounds counterproductive for something that should be well oiled, you'd think, but doesn't need it. Okay, cylinder goes on this direction based on the cam chain tensioner there. The arrows, so it's going to point down, you can kind of see in there. I'm going to actually set this on the surface and kind of work the rings. See how I'm using my fingers and squeezing the rings right there? The problem with these bigger bores is the taper that drops the ring in is a little bit thin, so it's a little more difficult to put the rings in. And if you need something to aid you, you can use a small flat screwdriver. You can see how this ring is not quite popping in. You just kind of want to put a little pressure on the ring.
Damn.
And it dropped in there. Watch out for your fingers not get them pinched. Go to the next one. Kind of work the piston. You kind of put, I'm just putting a little bit of pressure down on the actual piston to drop the ring down. And you can see it's not going in perfectly straight, and that's what's kind of holding up the piston, this middle ring. Lift it up a little bit if you're having some issues. Try again. Definitely nothing. I'm not forcing anything on this. If it doesn't want to go in, you got to lift up and try again. So there you go. So there's the second ring seated in there. And the last rings, you got to be extra careful with them.
A lot of extras. Robot usually doesn't use that many adjectives. Is that an adjective? A describing word? No, I don't know what that is. We don't know that kind of stuff. That's why we work here. No, but the key thing, like you said, is he's not forcing anything at all. Sometimes he'll rock the piston back and forth a little bit, side to side each direction. Don't want to mess up right now.
Yeah, and then unfortunately some of these bigger bore cylinders, they're like I said, the taper isn't,
What he's saying the taper is because the size of the spigot that drops down on the cylinder is so thin, the wall of the cylinder, that there's not that much taper leading in towards the piston. Normally it's tapered, so it's easier to do this, but again, dealing with some pretty high-end performance stuff, so they've maximized the cylinder bore and made that spigot as kind of skinny as possible.
There are special tools that clamp down rings on these. I've tried them. To me, they're a waste of time. I'd rather do it this way and verify that each ring drops in. I know it's a little bit more work sometimes maybe than using those tools, but those tools sometimes you don't get a good indication that the rings are, seated.
Not to break your concentration, but should I put this base gasket on yet, or?
Oh yeah, that's fine. So it comes with a base gasket. You want to put the 2 dowels.
So put the 2 dowels in first?
Yeah, and those dowels, we were able to salvage them. Again, if they're rusty, you might want to replace them.
And again, no silicone on this gasket, right,
No,
Robot?
nothing yet. It's already a treated gasket, so.
Kind of pull the cam chain, pass that thing through. All right, well, I did the super hard part of the operation by putting on the cylinder base gasket. Robot did the easy part, but he's got the rings all seated, and he's moving on to the next step. So actually show the back of that. So we kind of use that, you know, to kind of hold the piston in place, basically compressing the rings. That's a good little trick, and that's the best way to really do this.
And you see it's actually the pin's so close it's actually touching this skirt right here, and that's right where I want it. See how that slides in and out the pin. Already it goes, so pretty much Steve's gonna feed the cam chain through. Sometimes it's a little bit difficult. So use the magnet, grab the cam chain, and one little thing I always do, just throw a needle nose like that. That just kind of holds it. A couple other things you gotta watch. This cam chain guide is kind of once the, you know, there's only one little spot it can easily pass through, and you kind of got to watch that doesn't bind up. I got the wrist pin right here, ready to go through the connecting rod, small end, and you got to sometimes wiggle it because the piston is not 100, you know, perfectly parallel with
let's spin this thing real quick, so you can kind of see from the camera what's going on. Actually, we'll spin this way first. Show like that cam chain.
See that? And it's kind of going right there. And as we slide on, you got to watch that part carefully.
Okay, so that'll be my job. That's the technical job in this operation. And then you'll see on this side, Robot's already gone so far as to push the pin all the way in, and he was kind of having to rock the piston around just to get it to slide effortlessly in.
But I'm not pulling the cylinder away. You know, the rings have already been seated into the cylinder there, So go ahead and push that all the way in, and you'll expose the little clip. Good idea to kind of just shove a rag in there temporarily. Don't want to lose this little clip in that hole. Just for a second, Steve's gonna actually hold. If I had two needle nose, or you could use a magnet just like that. Check that out. See, it just keeps the chain from falling. Again, just like I showed in the other spot, grab the clip, you know, from the very edge and just work it in there. I know I'm kind of in the way of the camera, but it's exactly the same as when I did it the first time around.
Yeah, to really do this correctly, you kind of have to be spot on and directly in front of it. So sorry, for the sake of the camera, it's virtually impossible to do this without leaning over it.
And it's almost there. You want to hear the click? Heard that? That little click popped in. So.
You don't hear that click, you run the risk of ruining your brand new cylinder, and maybe more.
Rag can come out. Steve's gonna watch this cam chain guide
closely,
and we're just gonna rock this down all the way down, and you want to make sure cam chain guide does not come up where the actual tensioner
goes.
is.
I see what you're saying. These things are the cam chain guide is actually kind of has a little banana arc to it.
And sometimes with the Malossi cylinder, it's a little bit tighter in there, so you got to kind of just work it around.
So again, Robot's kind of walking the thing back and forth, never forcing anything. Pull the slack out of the cam chain.
And there it is, all the way seated. And it should be top to center. I can verify that through the little mark. Yeah, look in there with a flashlight, and I see a little T, and the pins.
Sorry,
the actual little pins.
Show you where he's checking that. Because right now, obviously, the valve train's gone, so you can't use those reference points. So you got to use that one.
The one on your flywheel right here.
It's looking faster already, I tell you. Look at that thing. It looks sporty.
So there, that's all good. Cylinders installed. We have all our parts clean that go to the top end. Auto decompression system, sprocket, cam tensioner, bolts, nuts, whatever. The gaskets are included with the Malossi kit. As a head gasket, you notice there's two base gaskets. I meant to mention this when I was assembling the cylinder. It includes a thinner and a thicker base gasket. This 0.8 of a millimeter gasket isn't used. with this cylinder. That's if you're using a stock head. We're not going to use that part, just throw that away.
So we use the thinner green base gasket because we're doing the Malossi cylinder along with the Malossi head.
That's correct. And next thing we want to do is put those O-rings that we were basically catching up on the threads. There's 4 of those new O-rings. There's a trick to installing them along with how we removed them here. Basically, the little bag that's included with your Malossi, whatever,
Oh man,
any bag.
I'm excited about this trick.
So basically, you just want to cut a little plastic, I don't know, what do you want to call it, condom?
Sure, we'll
Yeah,
call it that.
there you go.
Stud
So,
condom.
yeah, and basically, you don't want to ride these brand new O-rings over the threads because it'll tear up the O-rings. Put a little grease on them. This is assembly grease because we'll use this when we put the cam back in the cylinder head. But just basically a little grease on each one of these O-rings. They don't need much at all, but basically slide them right over. And there you go. So
Wow,
just Steve can do that side.
this is raw. I didn't know this trick was coming. I like it though, so I can do it. Oh yeah. Oh, that's sweet. I would call it a condom at this point. I don't know what you can call it. Oh wow, wow.
The O-ring protection system. So these two actually get the dowels, so they're a little deeper, the wells. These ones are a little shallow, and you kind of just basically work the O-ring in there real carefully with something blunt, like a kind of a blunt flat screwdriver. And you can see I'm kind of actually steering the stud around, so it's a little easier to press down. So see, this side's still a little high, kind of moving the stud around. It's real critical that you get these in carefully and don't tear up these O-rings, because this actually keeps the coolant and the oil separate.
Wow.
These little teeny O-rings. And any grease you get on the actual cylinder deck, I'm gonna actually wipe that off. I have that perfectly clean.
You probably would you use like a carb spray or brake cleaner or something
Yeah,
like
the
that?
last little thing before we put this head gasket, it's real critical that everything's clean, especially with the head gasket.
You gonna save this and reuse this, or we just use another bag later on?
Just use another bag. I just
Wow.
cut one out every time
right.
I gotta do one. So
All right.
I know it's the best tool we use yet, but you know.
Make a beautiful addition to
Okay.
a factory tool
So
wall.
see, you can see this O-ring is not as
Oh yeah,
deep.
I can see that. I don't know if the camera can see
Yeah,
that.
this one's gonna be deep. This one's gonna be deep because the dowel's gonna go in next. And
These
Steve's-
ones look practically flush. I mean,
And again, one of the key tips, see how I steered, he's pressing it? I'm pushing the stud 180 degrees away from wherever we're doing the O-ring. It helps it drop into the well a lot easier. All right, O-rings are all seat in. Soak a rag with a little bit of carburetor cleaner and just give it a little wipe, just to make sure there's no grease residue or anything on the cylinder deck. So got that all good. Looks good. Next, you want to put the cam chain tensioner. Don't want to forget this part, but it actually drops down. And actually, this little peg actually catches a little groove in the bottom. It kind of only goes in one way. And now it's sitting in that little well. Got your two dowels. Just drop those guys in.
is there a top or a bottom to those dowels, or they're the same? Okay.
No, they're the same. So no big deal. And then your head gasket's perfectly clean. See that little oil control, the oil hole? Oil hole's down here. So only goes on one direction. All right, got our cylinder head. Again, clean the surface on it. I already checked for valve tightness, and they were both perfect, or all 4 of them were perfect. Spigot's all in. You can see the cam and all that stuff isn't in. We could do that after the fact. Oops, not paying attention here. The intake's up here. So kind of and just pretty much drops right on. Make sure both dowels, and voila, it dropped right on.
You can see it fully seated there. Obviously no gap between it. Okay, next up we're gonna go ahead and install the 4 flange nuts that actually hold the cylinder down. Nice that they're flange, they can actually rest in your deep socket and kind of keep that down. And then you can kind of just push it on there. And you go ahead and hand tighten all these, and then we'll come back and do the robot will show us how to do the final torquing.
All right, we're gonna go ahead and torque the 4 head nuts. In the Malossi book, they actually say 24 Newton meters. And in the Piaggio reference, the latest Piaggio reference, they actually do torque angle. Basically, you torque all these to 7 Newton meters, about 5 foot-pounds, you know, in a crisscross fashion. And then they recommend that you torque them 90 degrees 2 times. So you go, you know, basically the first round, I'll hit them all at 7 Newton meters, set my torque wrench to 7 Newton meters, which is about 5 foot-pounds, which is pretty low torque. I'm not sure if you have a small torque wrench that's capable of that or a good digital one. Basically go on all 4 at 7 Newton meters. And then the second round, I'm gonna go 90 degrees. So basically torque at the 90 degrees, 90 degrees, 90 degrees, 90 degrees on all 4. And then one more round of 90 degrees. The older way of torquing with the 24 Newton meters, that's probably works just as well. You know, basically you just want to do them in increments. You know, don't go 24 Newton meters. You want to do it in steps. You know, preferably 4 steps. But I have my torque wrench. It's all set the 7 Newton meters, pretty much about 5.2 foot-pounds, somewhere in there. All the nuts are actually, they're all dry on the studs. There's no oil or anything on there. You actually get a different torque if they're lubricated threads. On there, 7 foot-pounds, or 7 Newton meters, 7 Newton meters, 7 Newton meters, and 7 Newton meters. Next, I'm going to set this torque wrench to 90 degrees. You could do it visually with 90 degrees. Just look, put a wrench here, turn it 90 degrees, but this thing, I could set it to 90 degrees. Basically calibrate it, 90 degrees. All right.
Wow, that's cool.
So basically I'll get it on the first one I torqued, 90 degrees. That's about 18 Newton meters right now. Actually indicates how much pressure it's actually put on the bolt. 90 degrees.
Look at the tongue, ladies and gentlemen.
And then now I'm going to do my second round of 90 degrees. So it's 26 Newton meters. So see, it's pretty close to what if you torqued it 24. So there's 26 again. 90 degrees. And there we go. They're all torqued. All right, torque these two to the 2 cam tunnel ones, like 10 Newton meters, 8 foot-pounds, perfectly adequate for these.
Those are those long flange bolts.
Yeah.
Once we finish torquing these, robot's going to move on to setting the camshaft.
Oop, can't see what I'm doing here.
All right.
There we go. We're going to go ahead and put together the valve train. Now that the cylinder head's all torqued. Got my cam. It's all lubricated with engine assembly lube. Same with the journals that the cam actually goes in. So gooey I can't even hold on to it. You got the 2 lobes. And actually the lobes will face down just kind of when we slide it into the actual journals right here. So it's got to be perfectly square to drop in. So there you go. It's dropped in. My rockers, again, I marked them with E. So exhaust goes down there, and I marked the end there. So basically, I'll drop that right in there and put the pin in. And if you're struggling to get the pin in, you may need to loosen your adjusters a little bit more. It's actually hanging up just a little bit, so May need to just give it a little tap. All right. So there you go. Not the best tool to use as a hammer, but it worked. Got your intake. Again, I marked it. Put the pin in the same direction I took it out. Again, gotta use my specialty hammer right here. It's a nice little light duty hammer. And I could tell one of these is a little tight. So there we go.
Good news, guys. My fantasy baseball team did all right today.
Well, that's good.
It's fascinating, right?
A little plate.
Oh, the little keeper. Nice.
And you got the little 5mm screw or bolts right here.
The keeper of the rocker arm shafts, huh?
Pretty much.
Goes without saying because we're not using it, but no need for Loctite on really any of this kind of stuff.
Yeah, just, I mean, those are pretty small fasteners. You don't want to over tighten them and break them off in the head. 8mm. We'll go ahead and tighten those. I got my little swivel guy. I can keep it on the bolt here. I just seated that one. I actually didn't tighten it. So now that one's seated. And just give it a little snugging. There you go. And we got the Mickey Mouse plate. Put that on. And we have our marked with 4V again. And I'm not going to hook up the cam chain, but I'm actually going to put it on and just make sure 4V points to that little hip right in the center. So, you know, I had the cam pretty close by just eyeballing the rocker arms and making sure they were pointed down. I'm going to actually fish the cam chain in there.
And again, through the whole process, we paid careful attention to always leave the thing at top dead center.
Yeah, you may want to double check that. Just make sure there's no issues that. And you can see it needs to be moved over a couple. And you can actually kind of lift the chain and just walk it around the sprocket to get it close to where it needs to go. And I'm not looking, I gotta look at it. Looks like we're pretty close right there. All right.
So you kind of rock the motor back and forth a little bit, right, to get it to seat?
Mm-hmm. And again, I have the mark here. You want to verify it in here. And it's still at the T, so we're good.
This would probably be like a step that the inexperienced or novice could potentially miss, wouldn't you say?
Yeah, and basically, make sure it's really close. You could put the whole thing together, turn the motor over 1 revolution, and find when this marks right at the T and dead centered in the thing, the hash mark. And as long as this is very close to that pip, you're good. Sometimes it might be just slightly off, and that's okay. But if it's a whole cam chain pin off, then you need to derail the chain and move the sprocket one over. So, and the engine will, if it's 1 tooth off, it's not going to run right. The little counterweight, you see it's got the little well right here. Got the screw. That's that screw that was difficult. Like I said, good idea to replace them whenever they. And I got just that little hand Allen. It doesn't need to be cranked. Yeah, that's all it needs. It doesn't need to be like really torqued on. So. Then you got the counterweight. You'd put a little assembly lube on this little shaft, and then same with the We're replacing that little nylon spacer. It was a little melted. A new one actually snaps on and kind of wants to stay. You know, the old ones, you know, they're a little bit loose, so they kind of want to fall off. I'm putting a new one on there. And drop that right on. Last is a little spring. See, it's got the two hooks. So here's the inner hook. I'm actually going to hook it onto that. And I'm going to rotate this out 180. That's all it needs to go is 180, and then you catch it on that edge right there. And last but not least is the bell.
What do you need?
8mm, I got it right here.
Okay, good.
So again, hold, and there's tools that actually hold this, but I've never seen it actually jump the cam sprout. I don't even have the cam chain tensioner in here, and it's not likely to jump, but I'll go ahead and torque that. So it's all tight right now. A lot of times I'll give it 1 revolution, or actually 2 revolutions on the crankshaft, just to check everything. So I'm looking at my mark right here. And we'll double check it, because every once in a while it will jump one tooth, or you have some little issue. So we're coming back around, and my mark's dead on right there, and I'll double check it again over here, and it's still good. So right now we're okay. All right, got my cam chain tensioner, got a new gasket. Again, I showed you in the earlier step how to reset that. Push the little metal tab and push the piston all the way in. And we're gonna set that in place. Kind of only goes in one direction. The 2 screws that hold it in place, or bolts. One thing to keep in mind, sometimes with the Malossi cylinders, they don't bottom out. And if that's the case, you're gonna wanna put a gasket, or I mean, not a gasket, a 6mm washer. But right now they're hand tight, and it's definitely bottomed out because that tensioner is pretty tight. A lot of times I'll go in there with a little screwdriver, push it down, you can hear it actually ratchet. And go ahead and tighten these guys. Again, not too tight. You want to get a torque wrench in there, like 7 foot-pounds maybe at the most. Spring drops in. Again, it's got the little crush washer. Some of them have a little well with an O-ring in there. And go ahead and thread that in. Tighten it with a 10mm wrench. And voila, you're done. And again, if you want to go ahead and turn the motor over, another 2 revolutions, line up everything, double check it again. All right, so I'm going to go ahead and set all the valve clearances on this. You can look at one of my other videos of how to adjust the valves. I kind of go in a lot more detail in that video and kind of show some of the specialty tools that make the job a little easier. Right here, I'm just going to show how to do it with a screwdriver and an 8mm box end wrench. Right now, I have all the lock nuts loose right now, and I did that in an earlier step, kind of when I took the rockers apart. But right now, I'll go ahead and just set all these where they bottom out. I'm not tightening them. I'm just basically turning them until they stop up against the valve, and that's as far as I want to take it. Again, in the cam set at top dead center. You know, I double, triple, quadruple checked it, made sure it was all right, and it's perfect. Yeah, after putting the cam chain tensioner, that is. You got your 6/1000 of an inch, 1/10 of a millimeter feeler gauge for your intake. We'll go ahead and do both the intakes. Right now I can't slide that in there because I have 0 clearance after bottoming that out. And basically just open that up, and then just right when the screwdriver has just the slightest little pressure, pushing that little guy right on the feeler gauge. That's as far as you want to take it. Put the box end wrench on there. Again, this is pretty easy when the engine's out. When it's in the bike, it's a little more difficult. Easier if you use some of the other specialty tools that I've gone over. And there you go. See, that slides nice in there. I'll do the same with the other one. With the exhaust, you want to set that to 6/1000, 1500ths of a millimeter. Again, I can't get in there because I have 0 clearance. Back this out. And right when it stops, get the lock nut, bottom out, and hold the screw in position and snug it up. And again, that slides in there just nice. That's just what you want. Just where it just drags through it. And I'll do the same with other ones. So that's setting your valves. Very important that you do that with a new head. And it wouldn't be a bad idea to check your valve clearance again after, I don't know, I would say with a performance head, maybe 3,000 miles would be a good idea to check it. Technically, these motors can go as far as 12,000 miles before needing them checked, but anytime you hop something up, not a bad idea to check stuff more frequently, change the oil more frequently. Went ahead and put the hose clamps for the two coolant lines. The main coolant line is pretty self-explanatory. Just put it over and then tighten the hose clamp. See, I got new hose clamps there. The smaller bypass hose, unfortunately on the Malossi kit, the little spigot's a little on the small side, so you need to actually tighten the hose clamp quite tight to actually shrink it down. I've never really seen these leak, but you definitely want to use a worm gear hose clamp and tighten it down pretty good. Then I'm installing the spark plug. All right, we're going to go ahead and reinstall the existing thermostat and thermostat housing. This is actually still pretty flat, but still, anytime you reuse this, you need to put some small amount of silicone sealant on the edge and let that cure up a little bit before you fill the thing with coolant. Doesn't need too much time for this to cure up, but go ahead and goo that up just a little bit, drop that in. Before you even put this on, you got to put that brand new O-ring in that well, that little teeny O-ring we talked about. So go ahead and drop the little O-ring in there. Don't want to put any silicone on this because it's so small it will probably clog up. Sits there right in the hole just perfect. Got the little hole right there, and voila. Go ahead and tighten the two Torx screws. You can see the reason I cut that little spigot off on that side. It doesn't actually clear the hose, so important to do that before you install the head.
And I believe the part number on that little baby O-ring, that's the 297027. O-ring it bleed screw or no?
Yep, that's
Okay.
it. Mm-hmm.
So Scooter West part number on that, 297027. And again, that's the O-ring that we recommended in the intro to the video.
All right, and the rest is pretty self-explanatory. You know, put the valve cover on. You can grease up the seal if you like. Before we wheel this motor back over to the frame, take a fresh rag, actually put it right in your intake hole. You don't want to have anything drop into your brand new motor, whether it be just a little bit of dirt or a large bolt or something you don't catch. I've seen it happen. Don't want to let that happen over, you know, ruin some expensive parts over some stupid little mistake. All right, get the valve cover on this. Put the motor in. You put the timing plug that goes in this hole. We can put that back in there because we know the timing's perfect.
These parts are pretty self-explanatory. Robots asked me to put these back on, so I'll start doing that. Probably don't need to videotape it. But.
It also, while the engine's out, it's a little easier to actually refill your engine oil. A lot of times when you're breaking an engine, it wouldn't be a bad idea to run a non-synthetic oil for the first 300, 600 miles. You can run, you know, just a conventional motorcycle rated MA, you know, 540 or 1040 is a break-in oil. Then you can go to the full synthetic oil that Vespa recommends for these motors. You know, 5W40 full synthetic.
And no sealant on any of these gaskets or
No.
anything, right? This thing has a nice molded lip that it fits right in this cool little recess.
And one thing is the Malossi head actually already has the exhaust gasket already installed in there. It's like a copper ring, so you do not need to put a gasket in there. And
Okay, so we've got our motor reinstalled to show you everything that we've reattached. There's obviously the one little special bracket that holds the cooling hose. Shares one of the belt cover screws. We've got all the belt cover screws installed. Taking note of the one airbox fastener up there. Again, that's the longer one, the black one where you have to reach through from the backside and install the flange nut. So that's done. The topmost airbox screws are the other two, one and then two there. Kind of working our way back down and around. The caliper's been reinstalled, so we've got those 2 bolts reinstalled and torqued down correctly. Wrapping around the bottom here, again with the belt cover screws. We've got the one that has this overflow, I don't even know, vent tube. That one's there. This one has got the little bracket that houses the brake cable. And then up front here, last and final, is the main bolt that basically connects the motor to the swing arm. Robot's dropping the motor down. I think that's everything on this side. And then obviously the clutch nut behind this cover. Kind of pan around and handed it off to Robot. He took care of this side. Oh, and we did the rear shock bolt, but on Robot's side now.
All right, engine pivot, it's all torqued correctly, and there's also that spacer that goes. And keep in mind the engine pivot, this little bracket goes on the outside, and then on the other side, the actual bracket goes on the inside of the engine thing, and then there's that spacer back there. So that's all torqued up. Muffler's all installed with the header joint. The O2 sensor is actually all installed, plugged in, and it's on this little metal bracket right here. You know, the little rubber thing that's on there. And up here, the O2 sensor wire loops around and actually zip ties to that smaller coolant bypass hose, just to keep it out of the way. And that's the way it comes from the factory, so that's the way I do it. Shock, of course, the whole swing arm support is 2 fasteners holding that to the engine. You got the center nut. There's also a small spacer on the outside of that bearing that's in that right-hand support. Wheels all been torqued to the disc brake carrier. And that's about it for this side. Got my lift out of here since it's sitting here right on the stand. Tire turns, get the lift out of here, and we'll go up underneath the seat and start connecting up wiring, install the throttle body, and yaddy.
Down we come, right?
All right, so all the business up on the top of the motor's all been buttoned up. Got the breather hose reconnected, just a regular HCL 6 mini hose clamp. New hose clamp here, HCL 12 soft. It's the nice quality ones. Have that. We got the thermistor hooked up, and there's a little rubber boot that goes over that. The injector's hooked up. Make sure the injector is actually turned to the far left, because if it's in the center, you're likely to break that connector. So you need to make sure that's in the far left. You can see it has a zip tie already here that kind of holds the wire. The 3 fasteners for the intake manifold have been torqued down. Didn't really touch it, but this is the hose that goes to the evaporative emission system, and it's all hooked up just fine. I didn't really touch it. On this side, you got the 2 clamps for the wiring. If you see this red tape that's on the harness, actually all the wires that pass through it, they all are wrapped with red tape, and that indicates that's where they'll be clamped down under these clamps. So kind of a good reference. Make sure they're snapped down. Definitely want to make sure these are good, and if they ever fall apart, you want to replace those clamps. Got a zip tie here holding some of the wires, leading to the starter, just like they did from the factory. Got the starter lead ground and the positive lead hooked up on the starter. Got the alternator connections all buttoned back up, and they're snapped back in place, and the plate is bolted down. Basically, this engine should be able to fill up the oil, fill up the coolant, bleed it. It should start up, and we'll go from there.
Hey, what's up, guys? So that's pretty much it. That concludes the Malossi cylinder head and cylinder kit installation on this Vespa 300. Robot's taking on a few test bins up and down Pacific Highway. Oil's filled, coolant's filled, coolant is bled. Verified there's no oil or coolant leaks. We definitely didn't expect that, but it's always good. You always want to double check that. We've also let the thing idle long enough for the cooling fan to cycle on to make sure everything's working on that in regards to that. So coolant's flowing, oil is pumping, and this bike is hauling ass. What else can we say, Robot? Break in, anything like that?
Yeah, just ride it easy, kind of just cycle the throttle. Don't do your top speed runs within the first 100 to 300 miles. Good idea to change the oil after 500-600 miles. Check your coolant level frequently. Check the oil level frequently. Top off if necessary. If you're gonna ride it hard, it's gonna use a little bit of oil. Other than that, they hold up pretty good. I have a couple customers that have over 30,000 miles on similar setups to these.
So that's it. Thanks, Malossi. Thanks for watching. Till next time, this is Steve and Robot signing off from Scooter West in San Diego.